All right, here are your guided notes on limiting reactant. All right, so the first thing is I'm looking at a recipe for making a grilled cheese sandwich. And here the recipe says for every 1 slice of cheese, we need 2 slices of bread to make 1 cheese sandwich. Okay, so now the problem here is if we have 5 slices of cheese and 6 slices of bread, how many grilled cheese can we make? And some of you guys can probably do the math in your head and say, okay, we can make 3 grilled cheese sandwiches with those ingredients. So in my head, I'm thinking, all right, so for every 1 slice of cheese, we need 2 slices of bread. Right? For every 1 slice of cheese, we need 2 slices of bread. So I'm gonna cross out every cheese and the breads that I'm using to make 1 grilled cheese sandwich. So what happens then is we know that we make 3 grilled cheese sandwiches with 5 slices of cheese and 6 slices of bread. And we know that we have 2 slices of cheese left over if we use up all the bread. So which ingredient do we have an excess of? Cheese, right? And which ingredient do we run out of that limited the production of the sandwich? Was the bread, right? We ran out of bread and we had cheese left over. So the limiting reactant in this case is the reactant that is completely used up in a reaction, right? It determines the amount of product formed. Okay, so we ran out of the bread, and because we had 6 slices of bread, we were able to make 3 grilled cheese sandwiches. The excess reactant is the reactant that is left over after the reaction, and that was the cheese in this example. So we're going to use this concept of limiting reactant in chemical reaction equations, right? So let's look at the synthesis of water. This is our recipe for water, for making water, right? We need 2 moles of H2 for 1 mole of O2 to make 2 H2O molecules. So in this example, in this problem, it says if we have 4 moles of hydrogen gas and 3 moles of oxygen gas, how many water molecules can we make? So it's like the grilled cheese example, right? In the grilled cheese example, we had 5 slices of cheese and 6 slices of bread. And we had to solve for how many sandwiches we can make. So I'm going to start by calculating how many moles of water, H2O, we can make with 4 moles of H2. So remember, we need to use our stoichiometry skills, right? Mole ratio skills. So 4 moles of H2. So we need to set up a mole ratio between H2O and H2. So if we look at our recipe, the mole ratio between H2O and H2 is 2 to 2. So we're going to end up making 4 moles of H2O if we have 4 moles of H2. So because this is a 1-to-1 ratio. And now I'm going to use 3 moles of oxygen gas to calculate how many water molecules we can make. So we have 3 moles of O2. So we need to set up a mole ratio between oxygen and H2O, which is 2 to 1, right? We have 2 moles of H2O and 1 mole of O2. We're going to cross out the O2 and we get 3 times 2 is 6 moles of H2O. So how many water molecules can we make using 4 moles of hydrogen gas and 3 moles of oxygen gas? We're going to say we can make 4 moles of water. We can make 4 moles of water because we will use up all of H2 and have an excess of O2. So essentially this means that H2 is our limiting reactant. it limits us to make only 4 moles of H2O, all right? And the excess reactant is O2. All right, let's look at another problem. We're gonna actually look at a set of problems to help you with limiting reactant problems. All right, so let's look at the synthesis of ammonia. We have N2, so nitrogen gas reacts with hydrogen gas to produce ammonia, NH3. If we have 6 moles of N2, we have 6 moles of N2 and 6 moles of H2, how many moles of NH3 can we make? So just like our previous problem, we're going to set up two problems, starting with the 6 moles of N2. And we want to know how many moles of NH3 we can make. So we're going to set up a mole ratio between NH3 and N2. Cross out the N2. And we get 12 moles of NH3. So that was that for that. And then, so now let's set up for 6 moles of H2. If we have 6 moles of H2, and we can produce 2 moles of NH3 for every 3 moles of H2. So I'm getting those numbers from here, you guys. So this is our recipe. We have to do 6 times 2, right? 6 times 2 divided by 3 equals 4 moles of NH3. So we're gonna circle. So how many moles of NH3 can we make? We can make 4 moles of NH3 because the reactant that produces less product is your limiting reactant. So we're saying that H2 is our limiting reactant because it produces less product. All right, so the steps I took here is I calculated the moles of product using both reactants, right? Both reactants. And then I picked the number of moles that is less because that is the amount of product that's going to be produced because of the limiting reactant, right? We're gonna look at another set of problems here. Number 2. And I gave you the steps over here. So number 1, let's read the problem first. If we have 50 grams of N2 and 20 grams of H2, how many moles of NH3 can we make? So now instead of giving you moles, I gave you grams, right? So we have to calculate, number 1, we have to calculate the moles of each reactant. And remember, we do that by grams divided by molar mass. And then after we do that, number 2, we're gonna calculate the moles of product using mole ratio. Use mole ratio. And then at the end, we're gonna circle the less amount of product because that's how much product is produced. So let's go step by step. So we have 50 grams of N2 and we wanna know how many moles that is. So we're going to divide. So this is divide by 28. 28 is the molar mass of N2, right? And I get 1.79 moles of N2. Now let's bring the 20 grams of H2 and divide by the molar mass. So this is the molar mass of H2. And I get 9.9 moles of H2. So we now have the moles of each reactant, right? So that was step 1. Step 2 is calculate the moles of product. So I'm just gonna bring these numbers down here, right? And do a mole ratio. So we have to use the recipe, we have to use the chemical reaction. And we wanna know how much NH3 is produced. How many moles of NH3 can we make? So I did 1.79 moles of N2 times 2. And I get 3.58 moles of NH3 And I'm going to also bring the H2 down and do the same thing using the mole ratio given by the equation, 2 to 3. So 9.9 mole H2 times 2 over 3 equals 6 mole NH3. So step 3, we're going to circle the less amount of products. So I'm going to circle 3.58 moles of NH3, and this is how many moles that is produced. All right, so keeping that in mind, we know that N2 is our limiting reactant because it produced less amount of product, and then H2 is going to be our excess reactant. All right, so next question asks what I just talked about, right? Which reactant is the limiting reactant? It's going to be N2 because it produced less product. And then H2 is the excess reactant. It's going to be left over at the end. Okay. All right. So number 4, how many grams of NH3 is produced? So as soon as you see the word grams, you need to think molar mass of NH3. You're going to use the moles you got from the previous question, or number 2, 3.58 moles, and multiply that by the molar mass of NH3, which is 17.04, and we get 61 grams of NH3. All right, so I know that was pretty fast. The reactant that produces less product is your limiting reactant. So that's for number 3. All right, so I just went over the guided notes. So